Well, hello everybody. I think this is the start of this talk. We are now live. I'm glad to see you here and glad to say hello to the million of people watching us live on YouTube, because I guess that there are probably many of those people. Designing functional and fluent API. So it's really nice. We have two trendy keywords there. We're on the full hype. Example of the visitor pattern, and everybody loves the visitor pattern. It's a very easy to implement pattern, very easy to understand, very easy to get wrong, very easy to mess with it. So yeah, let's do that. My name is José. I just put some links here if you want to check the content I try to publish on the net. Hopefully interesting content, or also kind of dated content, because I've been doing that for several years now. I'm a Java champion and a Java Rockstar, and unfortunately there are not that many more Java Rockstar now, because those were the day of JavaOne, which is now gone. So just before we start, I'd like to start with a word of warning. This is going to be mostly live coding, so I hope there are at least some developers in the room that will be interested in live coding. This was my assumption. This is Devoxx, so usually developers come to Devoxx. So if there are people not really interested in live coding, maybe it's still time to find another talk or something with bullet points and charts and KPIs and these kind of things that we all love, of course. So why the visitor pattern? Well, precisely because it's tough to implement. We all know that, right? The visitor pattern is a well-known pattern from the Gulf. There is this kind of wait double dispatch in it that nobody really understands most of the time. It reminds me an old story back in the 19th century, where Oxford decided to train the student with math and Latin. Now, why math and Latin? And the reason behind that was that math and Latin was so hard to understand that if the student could get it right, could understand that, then they would be prepared to understand any kind of problem they would face in their business life and maybe personal life. So I would say this is the same kind of idea. If you understand this way of implementing the visitor pattern, then probably you're good to implement any kind of tougher problem. Yes, that's it. And I was giving a talk with my friend Rémi Forax Monday morning here, not in this room, but here at Devoxx. And Rémi said something that was quoted by Stuart Marks, that he say, if you have a problem in your application and you wanted to solve it with the visitor pattern, then you end up with two problems, the problem of your application and the problem of the visitor pattern itself. This is probably true, right? This is probably true. Okay, so we are going to, since we all know that the visitor pattern is a simple problem, we are going to make it a little more challenging, try to make it functional, right? How to implement it without classes, without touching classes, with interfaces, with lambda expressions, and try to make it readable, trying to make it understandable, and take this way of implementing the visitor pattern to be able to design fluent and functional APIs in our applications. This is the Gang of Four. I guess you all know this book. If you don't, well, it's really worth reading, and this is where the visitor pattern is explained precisely. All right, so let me switch to my IDE. Hopefully this is going to work, and I will be needing this, because my sightseeing is not so good. So what do we have here? The visitor patterns has to visit some kind of graph of objects, right? And probably the most classical example of graph object that is used all over the place is a car hierarchy. Everybody understands that. A car has a body and engine. Usually it has wheels. Usually 4 of them, maybe less, maybe more, doesn't really matter. And in this car class, we need to have this accept method there that is going to take the visitor as a parameter. And at some point in the hierarchy, you need a top level object that is going to be able to take that visitor and forward that visitor to the different parts of the object that is known by this top level class. And on the other top-level class, on the other class, you just have an accept method with this kind of weird double dispatch stuff. In fact, this class is able to accept a visitor, but it doesn't do much because, in fact, the logic of visiting this object, what this visitor should be doing, is really implemented in the visitor itself. And this is where this pattern becomes interesting, because if you want to implement different kinds of logic, all you need to do is provide another implementation of this visitor, which is an interface, of course. So you provide your own implementation and you have your visitation logic, right? So on the other elements, that is the body, this is the engine, which is roughly the same, and this is the wheel. It really looks like a body. It's not the case in real cars, of course, but yeah. And the difference with this car is that this car is able, and this is going to be very important in the rest, this car knows about the body, the wheel, and all the parts that need to be visited, and this is the job of this top-level object to forward the visitor to the rest of the hierarchy. So what is this visitor? It's just a plain interface that is able to visit the different objects we have in our hierarchy, right? So this is a very simple interface. And what I need to do in my main method, and this is really how the Gov described it, I just need to implement this visitor interface with this set of methods. And you see that if you want to gather some information from all the objects you're going to visit, and this is said in the Gov, in the Gang of 4 book, that this visitor is going to take this information and to accumulate it in some kind of internal mutable state, right? This is how it is explained in the Gov. This is really 100% handmade, gluten-free, GMO-free, whatever, pure Gov stuff. And this is not that great to have that, because here, this visited stuff there, this visited field, is a mutable field, and if we want to go functional, then we will probably have to do something with it, because functions do not really like mutable internal state. So I have this visitor object, and what I'm going to do here, I created a car, which is a Renault. Sorry, I'm French, so I like Renaults. This is how it goes. And this Renault is going to accept a visitor. And of course, what I want from this Renault is to be able to get my visited property from my visitor. And now I'm facing the first compiler error of this live coding session. Why? Because this is the visitor here I have is of type visitor, and I don't have this get method on this interface. So that what I really need to do is use this var keyword there. And guess what? This var keyword is going to infer the type of this visitor local variable, and it becomes a non-denotable type. And now I can, yes, if I don't mess up too much, I will be able, oh, sorry, it's on the visitor, of course, not on this Renault. Yeah, and now I can call this get visited method using this var keyword, and I'm just going to print it out because why not? All right, let me run this code. And I can see, hopefully, that this visited string of character is kind of ugly, but it's really the concatenation of all the string of character I gathered from my hierarchy. Right, this is the first step. Now, if I want to go functional with that, I can't have this internal mutable state, as I just told you. So I'm going to get rid of it. Okay. I need to get rid also of this getter there. And now that I'm left with no internal mutable state, probably my visit methods here probably need to return this string of character there. Okay, so yeah, this should really return a string, and I'm going to return that just like this to make my code look better. Of course, I need to change this interface, because this interface has to declare that my visit methods are going to return something. So let me do that. And I'm going to say that instead of running a string, I'm going to put this in a parameter. I'm going to call it R and say that this is a visitor of R. So my visitor basically has one constraint here. Is it really a constraint? I'm not sure. That each visit method returns the same type, in fact. Basically, that's it. And of course, now I need to fix all this code which is not going to work anymore, because this visit method should return the type it's producing. And I'm going to say that, yes, this is the R that I'm going to have here. Why aren't you happy with it? Because maybe this should be a visitor of R. Yeah, great. And I'm just going to copy paste this on my engine and on my wheel also. And for the car, I will have a little more things to do, because yes, this is really an R type now, and I'm going to return this R. Sorry, I'm messing up with my keyboard. Okay, great. And of course, I need to gather all the elements I'm going to to take out from those accept methods. So this is our one object. This is going to be an R2 object. Maybe I'm going to change this code a little bit and say that, yes, this will.0 should accept the visitor. Nice. And this is going to return the R3 object. Okay. Like this. 1, 2, 3. So this is 1, 2, 3. And this is 4, 5, and 6. And of course, if I visit this, because this is the visitation of the car, and this is also going to return an R7. Now, what should I be doing? What could I be doing with all those variables? Now, I visited the different parts of my car, including the car itself, which is nice. This is exactly what I want to do. I have gathered all the elements of the results of the visiting of those different parts, and I need to gather all those elements together in a functional way. Now, we have this could be seen as a reduction, really, and we have a very nice way of parameterizing reductions in the JDK since Java 8, which is the collector interface. Basically, those set of R objects could be seen as a stream, and I'm going to put them in a stream. A stream of, sorry, R1, 2, 3, 4, 5, 6, and 7. This is a stream, so you need to import that, yes, please, and collect them using a collector. Not collection, really any kind of collector, right? And this is the right way of reducing and parameterizing the reduction of set of objects in Java. So how do I need this collector? Maybe it could become a parameter of my visiting. So let me add it like this. It takes an R object. I don't really care of the type of the second parameter. And the nice thing with this collector is that it doesn't have to return an R object. It can really return any kind of other type. So let me just say that this method declares this other type, and I'm going to return this other type because this is the result of the collection of the different elements of my stream. And I'm going to return that just like this. And if I go back to my play with visitor, this collector, I need to implement it, but it can really be, okay, this is not, compiler is not happy, it's giving me some warnings because I need to tell that this is a visitor of string, and I need to provide an implementation of this collector. And really, I can pass any collector I want to that. So those are strings of characters, so I could, for instance, join them in one element. Okay, so of course this get visited stuff doesn't work anymore. I'm going to put that in a variable. Accept, yes, that's nice. Let me get rid of this and just print out this accept method, run this code again, and now I'll have the concatenation of all the elements, and it's a better concatenation because I could add this separator. This is a parameter of this collector object, but I could have done it in another way. Let me pass the same visitor, the exact same visitor to my Renault car, and pass, for instance, the collectors.toList collectors. And this time, since the return type of the collector is really imposing the return type of the visiting of my element, it's returning me a list of strings. And if I run this code again, let me write it in another way. This is my list, and I'm going to use this nifty for each method and print out all the elements of my list one by one. This is a nice way of dumping the content of a list on the console, right? So now I have two ways, the same way of visiting the elements of my hierarchy, but I can reduce them, I can gather them using a way that is itself parameterized by the introduction of this collector, which is nice. I love it. I prefer that than the previous version of it. Now I'm more functional. The real problem now doesn't come from the fact that it's functional or not functional. I would say, by the way, maybe I could, yes, before we move on, maybe I could say that this should be, yeah, let me put this in another method that is really an accept method. Okay, in that way, nice. Why did I do that? It's just because I want to separate the fact that the double dispatch is done in a method and the gathering of the different elements of the visiting of my different parts, or the different parts of my car are separated in two different methods. So now it's the case and it's better. I don't really need that because most of the time the problem we have with the visitor pattern is that we need those accept method. And in this way we need even another accept method that takes a collector as a parameter. And I'm pretty sure that nobody has that on your model object. And model objects are most of the time the toughest things to change in real applications, right? Usually when you want to change a model object, you have to gather 12 people in a meeting room, and everybody will agree that yes, this model object sucks and we need to change it and we need to add methods on it. And then the discussion about what methods you need to add is starting, and then everybody disagree on what method should be added, of course. So model object is not touched in the end. So let us suppose that we don't have this code, in fact. Okay, we don't have that, because most of the time this is the case. We don't have that. We don't have this one neither, and we don't have this one neither, right? Our object model is not ready to be visited. It's not visitor friendly. It's an exclusive object model, right? And we don't like that, of course. This is not trendy anymore. So how could I call those accept methods? They do not exist anymore. So let me just comment out the code. It's probably a very good way to fix the compiler error. Comment out the code that does not compile. And let us try to do something else. Okay, I cannot implement this visitor in that way anymore, so I'm going to get rid of this code also. And here, having a visitor that knows about cars, body, and engine and stuff is not worthy anymore. So I'm going to get rid of this code also. So yes, now this is very functional, right? I've got a visitor that takes any object. It has only one functional, or it was only one abstract method, so it's a functional interface. I love functional interface because I can implement them using lambdas. And I love lambdas, that's for sure. So how could I say that this visitor is able to visit the different types I have? Well, I could try to put, you know that the Gov is telling us you should favor composition over inheritance. So we are going to use composition. And all the methods we removed from the classes, we're going to put them somewhere else in lambdas. But we still need to link them to the original types, right? So what we need, the structure we need, is probably a map structure that takes a class as a parameter and the function. And this function is going to take any kind of objects, because those objects are going to be my cars, body, wheels, etc. And that is going to return a string, because this is what my visitor is doing, producing strings for the moment. Let me call that a registry. It's a regular hash map. So yeah, let me just put it here. Yes, hash map. Thank you. Fine. And in this hash map, I'm going to put the fact that the car class is visited using this lambda, takes a car and returns visited car plus car. Okay. And the same for the body, for the engine, and for the wheel. So I need to add this code here. My body, my engine, and my wheel. Not chill, wheel. Thank you. I just like the body. Oh yes, you liked it. All right, great. And this is the body. And this is the engine. And this is the wheel. I'm just going to fix the code. Body here, and body here. Engine here, here. Gosh. And here, and wheel here, and there. All right. And now I need to implement my visitor, but implementing this visitor is going to be very simple. Why? Because my visitor is just a simple lambdas. Let me check this out. This again. A lambda that takes any kind of object, and that is going to return an object of type R by applying one of the functions I have in my registry. So I'm going to take any kind of object. I need to get the function I just put in the registry by calling the get method on the class of this O object and apply that on my object O, right? And this is my visitor. Now, I'm not quite done with it, because all my visitor is going to be able to do is call this visit method. So I'm going to call this visit method on my Renault car. So this is my visit stuff, and we're going to print this out. And I can also visit maybe the body, visit card.getBody. Oh, sorry, it's my Renault. GetBody. Put this in another variable and just print out the result. Let me run this code, and I can see that, yes, this code is working properly. I can visit both my car and my body. I can't say I'm too happy with this code because I really don't feel like mixing some kind of technical code. This registry is really some kind of technical code. It really belongs to the visitor. So I need to find a way to write this code in a different way. This is what I want to do. Now, if I check this code here, I can see that basically I am just doing the same operation over and over again on a set of business information, the type and the function I want to apply on that type. So let me just show that in my code and saying that all those lines of code are in fact by consumers of types and functions. So I'm going to write this as a by consumer. And I love by consumers because those can be implemented using lambdas. And we're going to do that. So by consumer of type and function of object and string for the moment. Let me call it by consumer. We're going to change that, don't worry. And it's going to take a type and a function and just do registry.put of this type and this function. And now that I have my by consumer, I can say that this code here is not registry.put anymore, it's by consumer.accept, right? This code is just running in the same way. And this by consumer can be seen, in fact, as a builder. This by consumer really builds this registry over several steps. So I'm going to call it builder. I'm going to cut that. And this is a visitor builder. Let me call it like that. Visitor builder of string. And I'm going to create the corresponding interface. Yes, here, fine. I'm going to say that this is really a visitor builder of R because that's the return type of my visitor. And it extends my by consumer of object and string. And this is, in fact, of object and R, of course. So this is now by consumer. Maybe I could rename that and call this visitor builder. Yes, that looks better. I could even rename this method accept because this accept method, this is really the name of the technical method of the by consumer. Since this visitor builder is doing the registration of my key value pairs inside my registry, I would like to call this method register. Now, I cannot rename the accept method of the by consumer interface because it's part of the JDK, so I can't do that. But I certainly can create a default method on the visitor builder, and this is what I'm going to do. Say that I need a default register method that is going to take the type and the function of object and R. This is my function. Nice. And I'm just going to wire this call on the accept method that takes the type and the function. Okay. This accept method is defined on a by consumer interface, and I'm happy to write it in that way. This is kind of useful and useless at the same time because it's just a matter of improving the readability of your code, right? Having meaningful methods, and this is what clean code is about, improving readability. So yeah, I'm kind of happier with this way of seeing things. I've separated the business logic to the technical logic. I can go one step further and say that this code here is in fact consuming this visitor builder. It relies on the fact that this visitor builder has been created. And the creation of this visitor builder here only relies on the creation of the hash map. So it's really 100% technical code that belongs to the API and that does not belong to my client code. So let me rewrite this code as a consumer of visitor builder of string. All right, and I'm just going to call it yes, consumer, why not? Fine. And this consumer is going to take a builder as a parameter, and it's just going to wrap all this stuff there, like this. Okay, and this is my builder here, really. Great. And now what I can do is say my consumer should accept this visitor builder, right? And I'm going to use the same trick as previously, just to improve the readability of this technical code. This consumer is in fact initializing my visitor, so I'm going to call it visitor initializer, because why not? Yes, this is nice, I like it. I'm going to create this as an interface. Initializer. I guess I should put an R here to call it initializer. Oh, not capital R, please. Yes, like this. And I'm going to extend my consumer of visitor builder of string, and this is the return type of my visitor, so this string is the type R here. And now my code is kind of working properly. So now I can rename this and call it, yes, visitor initializer. And maybe there I could create an init method instead of having an accept method and use the same trick as previously. Make it a default void method that is going to be called init, and it's going to take a visitor builder as a parameter. Let me just call it builder. That's going to be enough. And just wire this method on the accept method of the consumer I'm extending. Once again, this is just about improving the readability of my code. And of course, if I run this code, it should work the same as previously, hopefully, and it does, which is really nice. Now I'm much happier with this code because what I have here is really good separation between some kind of client code. This only relies on types provided by my API. It only relies on the fact that I know which key value pair I need to put in my registry. And this part of the code is really purely technical code. It's creating my registry, it's implementing the visitor, creating the visitor builder, etc. So I'm going to put that in a method that is going to become a factory method and it only takes this visitor initializer as a parameter. And this factory method, I'm going to put it on the visitor interface itself, because it's really a factory of visitor. So I guess it makes sense to put it here. I'm going to say that the string is in fact a type parameter and rename it as a R. Never tell my student that you saw me doing that, please. And I'm going to replace this with a method reference, and I don't need this visitor builder variable anymore. Remember, I'm in the API code, so this code can be as ugly as it can be and as unreadable as possible. So this is the case now. Great. And my code here is probably as readable as it can be. Maybe we can still improve this. This visitor initializer has still the structure of a consumer. And I can't say I'm too happy with it because I don't want to expose it in that way. I want to create this visitor initializer in a fluent way. So let me just copy paste this here and comment this code there like this. Okay, great. And let me create some kind of factory method. How I would like to create this visitor initializer is the following. I would like to say that for the type carded class, then I want to execute, let me put it in that way, this function there, okay, and then for the type body class, I want to execute this guy here, something like that. And the same for the engine, and the same for the wheel. This would be a very fluent way of writing things, and probably easier not to mess up with while writing this client code. This is what I would like to do. Okay? So of course it doesn't compile because none of this code exists, so we are going to create it. I'm going to first begin by creating this one. What I need on my visitor interface is not that bad. I need a for-type factory method that's going to take a type as a parameter and that is going to return another type with an execute default method on it. So let us do that. we need a static method. I guess we are going to need this R type. I don't know what it's going to return, so let me call it X, just because I don't know, okay? Some kind of unknown type. This is a for-type method, and this for-type method is going to take a class as a parameter, and return something, and for the moment I don't really know what I'm going to return, so I'm going to return null. This X, I'm going to make it an interface, because today I don't like classes, so let me make it an interface. I need this default, sorry, this is my interface. Great. Oops, what did I do? And on this interface, I need a default method that is going to return. What is it going to return? Well, it's going to return my visitor initializer directly. So this is nice. I know the type I should be returning. Visitor initializer, it's called execute, and it takes a function that takes an object and return an R as a parameter. All right, and I know how to implement this visitor initializer because it's a plain consumer of visitor builder. So this really takes a builder as a parameter, and on this builder, I'm going to call register of my type and my function. And now I realize that this type is not known from the instance of this interface I am in, right? This type is known in the for-type class there. So how can I pass this type information there to this instance there? Well, I'm quite lucky because I haven't created any kind of abstract method in this interface, so let me do that. I'm going to create an abstract method type. So here I'm just going to call type, and now it makes this as basically a supplier, right? I could have made it supplier. So let me just implement it with the supplier and say that yes, this for type method just return that. And now my client code here is compiling, quite obviously. I guess it's missing the string type here, yes. And if I run it again, I should be able to visit my runner again. Okay, I'm not able to visit the body, but I'm able to visit my runner. Let us do the same for the second line. Now, the second line is a little different. Why? Because here I also have a for-type method, but it's not a static method anymore. It's an instance method of the type returned by this execute method there. Now, what is this execute method is returning? It's returning a visitor initializer, and I don't feel like touching this visitor initializer. So I'm just going to say that this is going to return another interface called Y, because why not? That's a good reason, right? Okay, and this Y is going to extend visitor initializer. So now it's almost compiling, and now on this Y method, I need this for type, a default method there. So now this for type default method, I'm going to run it in that way. We are going to think a little about the type it should return. Sorry, it's called for type, and it's going to take a class as a parameter. I'm going to call this class type. Now, on this for type object return, on the object returned by this for type method there, I need to have an execute method there. All right. The execute method is precisely defined on the X interface. And it turns out that I can directly return this X interface. And I love that because what I can do is say that, yes, you're going to return the type as a supplier. Great. And now my code is running properly. Can I visit my body? That would be nice, no? Well, it seems I can. Great. Can I visit the car itself? We're out of luck here. The reason is that, in fact, each line is able to create a single consumer that is going to take the registry as a parameter in an indirect way and add that key value pair there. But each line creates one consumer. And so I've created two consumers there, but the second consumer is not taken into account there. All right? When I add the second key value pair, I forgot about the first one. The trick is that this execute method there that returns a Y is nice. Hang on. The trick is that this for type method here should not return an X, because when I am in this Y consumer, I need to remember this Y consumer and chain it with the second consumer I'm going to create, right? And I've got an API for that. I've got an and then method and consumer that is able to do that. So instead of returning an X there, I'm going to return a Z. I hope we won't run out of letters. Well, we have more left. We can go around the alphabets, right? So this is going to be a Z interface. On this Z interface, I need this execute method there. I'm just going to copy paste it, right? And this execute method should be something more. It's creating a second consumer, but it really should take the previous consumer, okay, and chain it with the new consumer it's creating. This is the trick, and this is not the same execute method as the previous one. So now I need two default methods there. The first default method that is going to return a class, and that is called type. It can't be an abstract method anymore, because if I have two abstract methods, it means that I cannot implement Z with a lambda, and this is really something I want to do. And this previous method that is also going to be a default method, Y of R, and that is going to be called previous. And for the moment, I'm going to say that it's return null. I've got a problem with the compilation of this method, mostly because the and then method of the consumer interface cannot accept the Y type. This comes from the way the type system is working. So in the Y interface, I'm going to create this and then method, returns a Y called and then, takes another consumer. Remember, Y is a consumer. There are good. It's not because why not. There are good reasons for that. Okay, and I'm going to return the consumer. So the consumer I'm going to return takes the builder, and it's first going to consume this builder with the argument I'm in, with the consumer I'm in, and with the consumer I'm passed as a parameter. Okay, and this is, if you check the code of the consumer interface, this is basically exactly the same code, right? So I've fixed my compilation problem on this and then method. Now I need to find a way from this for type method to pass both the type that I'm given as a parameter and the instance of Y I am in, right? So this method should really be returning two objects, one at a time. There's a dirty trick to do that. I'm going to show it to you. You just pass an index and say if this index is equal to 0, then return the type, and if it's equal to 1 or something, some other value, then return this. And if you want to create the model for this stuff, we could call this method get, just takes an int as a parameter and returns any kind of object. And now if you want to implement the type default method there, you need to cast, that's not really nice, called get0, and does the same here with the previous. Make the cast and get 1. And this should do the trick. If you have more than two objects to pass as parameters, you can also do that by passing an array, for instance, and use the same kind of trick as here. So now my code should be working. If I hit the right button, I can visit both my body and my car and the car itself. And if I uncomment that, it's going to work properly also. Now, this one last point I need to fix with this pattern is that this car here is in fact not a car. You see, it's very easy with lambdas to cheat people, and I kind of cheated you, sorry for that. If I say that this car is a car, why do you think it's a car? Because I called it car, right? But it's really an object, in fact, because if I try to make it a car, you can see that the compiler is not happy. It's telling me, hey, you're telling me that this is a car, but it's not a car. I see that's an object. And this is really annoying, because here it means that I cannot call the methods defined on the car class. Where does it come from? Well, it comes from the definition, the parameter, the signature of this execute function here. What I really would like to have here is a type T, right? And here I would like to have the same type T to make this object the type of the type I pass here as a parameter. This object should be a car, and this is the class I'm passing here. So this type T has to be defined at the interface level. Now I've got another problem. Well, I've got two problems here. Okay, so let me say that this returns the type T. So I need the definition of this T type there. It makes this class of type T, which is fine, fixed. And the second problem I have here is that now I got a function of T and R, and this function does not extend the function of object and R that is put in my registry. So I'm going to use another trick here. This talk is full of tricks. I'm going to cast the first elements of this function just by using the class.cast method here. And now the problem is fixed. And this is nice because now this is not compiling because I added a type here. This has fixed its execute method there, but if I'm saying that this is a body, sorry, if this is a body, I will have the same problem because remember I have two different execute methods. This execute method is not the same as this one. So I need also to fix this execute method there, telling that this type is the same as this one. Great. So my Z type should take the T. I will have the same problem here. So let me compose you with this type column cast just to fix that. Great. And I have now the T type there. And of course, I don't want to propagate this T type on the Y interface because the Y interface only depends on the type returned by this visitor. So I'm going to define this T locally there. At least it has fixed my compilation problem there and has also fixed it here. And this should be an engine. And this should be a wheel, which is the case. So now I've got a fluent way of creating this visitor. It's also type safe, despite the fact that my registry is a registry of type and function that takes an object and return an R. But this, I can't really touch it. I'm not quite done with it. Not quite done because what I need in the end is an accept method there, right? So far we've just have done half of the job, which is create those visit method. So let us use the same kind of approach, creating lambdas and creating factory method and stuff. You see that my visitor is really a lambda, it's a lambda expression, but this lambda does not appear in my code. I'm not really interested in exposing that detail of implementation. All I expose is really a Fluent API to create this visitor and then to use it. What I would like to do is say, okay, I need to make this car visitable. So I probably need another interface, visitable. I'm going to call it visitable Renault. And probably I'm going to need to use an object to make, sorry, yes, this is the method. Make visitable and pass my Renault as a parameter. This is what I want to do. And this make visitable will be probably on the, I don't know, a visitable factory. Visitable factory make visitable. And let us say that this visitable factory of car is the type of my visitable factory. I prefer to write it in that way. Okay. And we're going to think a little about how creating this factory. And if I do that, then I should be able to run this code again, because my visitable Renault should be able to accept this and accept that also. Could you import this for me? Thank you. Oh, the list also. Forgot about what the list is. No, that's not nice. Great. Okay, so how can I create this visitable factory? I want to create it by saying that when I visit, so let's say visiting this car class, all right, is going to collect from, and here I need to put my set of method that is going to explore the graph of objects I have. So maybe the car itself, the car.getBody, the car.getEngine, and let me do this for a single wheel. This one, thank you. Car.get wheels and get the first element of that wheel. That would be nice. Okay. So I'm going to create this interface because I don't like classes today. Usually I like them, but not today. I don't know why. Why don't you want to oh yeah, you need to, yeah, create interface. Let me put it here. So visitable factory of t, that's nice. I need a factory method on it. So static is going to be parameterized by the type t. It's called visiting. I don't know what it's going to return, by the way. Oh, it needs to return an object with the collect from on it. So let me call it x. And now I can reset the alphabet. Yeah, I like it. And it takes a class of t as a parameter. All right. I'm going to create this x as an interface, because I love interfaces, at least today. Okay. And this interface will have to get this t type. So I'm just going to use the same trick as previously and return the t type there. So this is the type method that I need to implement, and that returns this class. Great. And now I need a default method on this. This default method is going to return the visitable car. So, visitable factory. So visitable factory of t, and it's called collects from. And what does it take as a parameter? Well, it takes any number of functions. So let me write it in that way. Functions that are going to take the types of object t, which is the car, the root object of my hierarchy, and that is going to return really any kind of object. It could be the car, the body, the wheel, whatever. So it's really an object. There's no real type for this, is it? And this is going to be my functions. And the use of this visitable factory will be to have a make visitable car, right? So I need to remember those functions somehow. And since I know that in the end I will have to collect those, I'm going to say, okay, this is going to be a supplier for the streams of those functions. Just like that. So it means that my visitable factory has to provide an abstract method that is going to be implemented by that. So this is really a stream of function that takes the type t, returns any kind of object, my body, my engine, etc. And I'm going to call that functions. Import the stream, and that's it for the stuff. It's not compiling because there are issues with the function. I'm going to just suppress warning, and since I never really remember what should I get to this guy, I'm just going to get old, and that will be it. All right. So now on this visitable factory, I need to have this make visitable default method. So let me add it. Default method that is going to return a visitable object of type t, make visitable, that takes an object of type t as a parameter. And remember that all this should, all that stuff, oh, didn't create that? Apparently I did not. Okay. It will be better now. Okay, great. I'm lost, and yes. Oh, visitable. No, it's not visitable, it's visitable. Please. Thank you. So what I have here is the car I want to visit and the certain function that I need to apply to this car so that I can visit all the different parts of this car. So what I should be doing is returning something like that. I'm going to return it as a supplier once again. Take this stream of functions, and for each function I need to apply that function to the object I'm passed as a parameter, right? And I need to provide a default method in my visitable interface that is going to match this signature. And this signature is just a supplier of that's still a stream of object that is really any type of object, because it's all the objects that I have in under my car, the body, the wheels, etc. So I'm going to go there and say that this, I've got an abstract method here, and I'm just going to call it get, that returns a stream of object, and this should be running. This should be compiling properly. Now, if I visit this, on this visitable car, I now need an accept method. This is the final method I need to implement. That takes the visitor and the collector that I already saw. So let me go there. This is going to be a default method, quite obviously. And I know that I need the two types because it's the same method I've already implemented. It's called accept. Takes my visitor of R as a parameter. Takes my collector of R question mark and RR. All right, and what I need to return is the stream of the different parts of my car that I'm going to map. This is a O, and I'm going to map it with this visitor. It turns out that this visitor is returning me a stream of R that I can just collect using my collector that I have here. And by the way, this is a method reference, so why not putting it that way, which makes this implementation really very simple in the end. So now I've got my accept method, and if I run this code, I should have the exact same result as I had previously, which is very nice. I love it. So that's it for this talk. This was a quite lengthy live coding session. You can see that by doing that, we made it possible to create more methods on an existing set of objects, running from a root object, and implement this visitor pattern using both a Fluent API and also a purely functional approach. I hope you liked this live coding session as much as I liked preparing it for you. So thank you for your attention, and have a good day.